Welcome to Study Loop.
All right, we've got a question here that describes a plane is flying at a constant speed, 300 kilometers per hour. It passes over ground radar station, altitude of 1 kilometer, and it climbs at an angle of 30 degrees. We want to calculate what rate is the distance from the plane to the radar station, increasing a minute later. All right, first of all, we want to go ahead and draw out a figure. And we would have we've got A, point B, point C. And then this angle here is pi over 6. And as we're told, it's 30 degrees. And then we're told that this distance is 1 kilometer. Okay, this will be point P. We know our plane is P. All right, now we want to figure out at what rate is the distance from the plane to the radar station increasing a minute later. Okay, so if we let the radar be at point A and the plane is point B, actually, this will be the plane and our radar will be here. We know that it's climbing at a rate of 30 degrees, which is pi over 6. Then we can write out the angle A, B, and C, ABC, to be equal to pi over 2 plus pi over 6. Okay, and the reason why is because we have this angle 90 degrees there, and that would be your pi over 2. Okay, and we go ahead and plug that in. Calculator, you will get something. You will get 2 pi over 3. And then if we use the triangle property, we can calculate cosine of 2 pi 3 for this triangle to be the same thing as the distance from AB squared plus BC squared minus AC squared. Okay, and we would divide that all by 2 times AB distance multiplied by BC distance. Okay, now if we let AC, so AC, this distance here, be equal to Y, we can condense some of these variables. And if we let B to C be equal to X, right? Okay, let me go ahead and use a different color. Use red. Let that be Y. This be X. And we already know that our AB would be 1, right? We have 1 here. That 1. Got 1 there. So if we go ahead and plug that in into this equation, we will have an AB squared. And AB is 1, so 1 squared. And then you have a BC, which you know is X squared. AC, we've already said, is Y squared. And then AB is 1. So you have a 2 multiplied by BC, which is X. Right, and then if you plug this into the calculator, cosine of 2 pi over 3 is the same thing as negative 1/2. Now we can simplify this equation here so it's in terms of y. So you have y squared would be equal to negative half times 2x. 2's would cancel out. And then you have a negative 1, negative x squared, and then all of that in a negative. So you would have a y squared is equal to a positive 1 over x, excuse me, just positive x, plus an x squared plus 1, and we'll rewrite this so that the larger variable is in front. All right, now the distance climbed after 1 minute, we can say is the same thing as 1 over 60 hours. And if we plug that in into our speed, which we're told is 300 kilometers per hour, and we can say after 1 minute, 5 kilometers has been crossed. Okay, so we could say that this distance here, I'll do green this time, x, if it's going at 300 kilometers per hour, then that would mean that it's going in 1 minute, it would have traveled, right? If you have 300 kilometers per hour, then you have 1 hour is equal to 60 minutes. And so you would say that you traveled in 1 minute. Right? 1 minute, you traveled 5 kilometers. Okay, and that'll be equal to our x. So then your y, you can calculate by plugging in 5 kilometers for x. You would say y squared is the same thing as 5 kilometers squared plus 5 kilometers plus 1, which would be 25 plus 5 plus 1, which is 31. And then y would be equal to square root of 31. Okay. Now, once you get to that point, you can differentiate this equation with respect to t and plug in the values that you've been able to calculate, okay? So you would differentiate, excuse me, not this equation, but you would differentiate this equation with respect to t. So you would get d of y over x, or 2y, excuse me, dy over dt, should be a y here, dy over dt, is going to be equal to 2x dt, 2x dx dt, plus a dx dt. Right, because if you differentiate this, you get a 2x multiplied by dx dt, and then you get a dx dt here, and then the 1 just goes away. All right, now if we solve for dy over dx, we would have a 2x plus 1. If you solve for dy dt equals to 2x plus 1. Right, if you factor, if you simplify this into one term, then you have to divide it all by 2y, right, because you have a 2y here. All right, and so now finally, if you plug in all the values that you have x equals to 5. You have 2 multiplied by 5 plus 1, 2 multiplied by y, which we know is square root 31. And then our change in x over change in t was going to be 300. That's what we're given. And if you plug that into your handy dandy calculator, you should get a value that is equal to 296 kilometers approximately. 296 kilometers per hour. All right, so we can confirm that the the rate that the distance from the plane to the radar station increasing a minute later was 296 kilometers per hour. All right, well, I hope that clarifies the question, and thank you so much for watching.